So in this video we're going to look at one of the four basic transformations. This time we're looking at rotation. So rotation comes in three basic types. There's a 90-degree rotation, a 180-degree and a 270-degree rotation. Let's have a look at the 90-degree first. So we're going to actually move the Euclidean plane to show the transformation, which simply means turning the paper in an anti-clockwise direction, like this. So the reason why we're going anti-clockwise is that way we can use the same standard that we use in trigonometry. So we set the standard direction as anti-clockwise. Now, if we look at the second one briefly, the 180-degree transformation, that's then going to go all the way around, not a quarter turn but a half turn. And if we have a look at one of the squares here, let's see where that ends up as we turn the paper right the way around. Okay, so that ends up there. And again, to give you a sense of this, let's just keep an eye on our 270-degree rotation. Which goes 3/4 of the way around and ends up there. Okay, so there are three parameters that we need to set when we're specifying any rotation. So the first one of these is the angle through which we're turning it. The second is the direction, and we're setting this at the moment as an anti-clockwise direction. Anti-clockwise. And the third parameter is the center of rotation. And what we're doing here, as we're looking at basic rotations, is setting the center at the origin, so 0, 0. So we've got three angles that we're going to go through. We've got 90 degrees, 180 and 270 degrees, but we're going to set the direction as anti-clockwise, and we're going to set the center at the origin 0, 0. Okay, well, let's give ourselves a little problem then. So we're going to draw a triangle, and if we start here, go all the way around, we can label our vertices so that we don't get confused. A, B, C. Okay. So let's start with the 90-degree rotation. So we simply want to know, problem A, we simply want to know if we rotate anti-clockwise about the origin 90 degrees, where's the image of ABC going to be? Okay, what are the coordinates of A, B and C prime? Well, there is a very simple way of calculating those coordinates without having to use tracing paper, protractors and all those kind of geometric techniques. So let's start with that method, but we need to be aware it only works when we set the center at the origin, because what we're relying on here are the coordinates, and because the coordinates come from the origin, it only works if the center is at the origin. Okay, so if we look at A, it's got coordinates of 4, 5. So A is 4, 5. What we want to know then is what is A prime. Well, there's a little trick. For a 90-degree rotation, if you have a look at what happens, so if you examine this carefully, what you should find is that the x component, so 4 in this case, the x component of the image becomes not the y component, but the negative of the y component. So it becomes minus y of the object. The y component of the image is simply the x component of the object. So now that we've got this formula, we should be able to calculate A prime. So A prime is going to be the y coordinate but negative, so minus 5. And the y component Okay, the y component is simply the x of the object. So 4. Okay, let's do that for the other 3 coordinates. So b prime, well, b is 2, 0, so it's going to be, well, the x component of the image is going to be y, so 0 but negative, so that's just 0. And the y component is simply the x component, so 2. Finally, c is going to be, again, the y component is 0, so negative 0, which is just 0. And the y component of the image is x, so its x component is 6. Okay, so that's, if you like, a quick way of getting the image, getting the new coordinates of the image, simply by following this, if you like, formula for the 90-degree rotation. Okay, let's plot them on our graph and see if it looks like a 90-degree anti-clockwise rotation. So a prime is minus 5, 4, so minus 5, 4, so that should be here. So that's a prime. B prime is 0, 2, so 0 along, 2 up, so that's here, so that's B prime. And C prime is 0 along, 6 up, so that's here, C prime. And now, if we join these together, okay, we should have a convincing rotation. Right, well, let's go ahead and do 180 degrees and go on to do 270 degrees. So what about the, so problem B, what about the 180 rather, the 180 degree rotation? Well, again, we've got a simple trick. We simply define the x component. We simply take the x component of the object and reverse its sign, so make it negative. Okay, for the y component of the image, again, it's just the y component but negative, or reverse the sign. So even simpler for the 180 degree. Let's see if it works. So again, we've got a is at 4, 5, so now we're going to just make these negative, so minus 4, minus 5. So let's call this a prime prime, minus 4, minus 5. B prime prime is going to be then, so B is 2, 0, so it's going to be minus 2, 0. And C prime prime is simply minus 6, 0. Okay, so now all we need to do is plot these on the graph. So minus 4, minus 5 is going to take us to here. Minus 2, 0 is here. And minus 6, 0 is here. If we join these together, so we've got a prime, prime, b prime, prime, c prime, prime. If we join them together, we should have a 180 degree rotation. And we can say anti-clockwise or clockwise because, of course, that would produce the same result. Okay, finally then, let's call it problem C. We're going to look at a prime, prime, prime. And again, we need to just think about what's going to happen to the x component of the y component. Well, this time the x component of the image is going to become simply the y component of the image. So if you like, different to what we had up here, but the y component of the image, instead of being just the x component, is the x component with its sign reversed, so minus x0, x of the object. Okay, so that's the formula, if you like, for 270 degree rotation. So we've got A is 4, 5. So the x component becomes the y component, so it becomes 5. So 4, 5, 5, but negative 4. B prime 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 is going to be, well, negative 0, which is just positive 0, which is just 0, and negative 2. And C prime 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 is going to be again positive 0, but negative 6. So we make the y component negative. Okay, so again, just plotting these on the graph, we have 5, negative 4, 5, negative 4, so that's here. We have 0, negative 2, so that's here. And we have 0, negative 6, so that's here. So we've got A prime prime prime, B prime prime prime, and C prime prime prime. And if we join those together, we should have our final 270 degree rotation. Okay, so what happens though if we don't know, or we don't have a centre of rotation at the origin at 0, 0? So let's suppose, for example, we had something like this. Then we can clearly see that the centre of rotation is no longer at the origin. In fact, it's now at the centre here. So if we call this problem D, then the centre has moved from the origin to, what would it be? It's a 180 degree rotation. Clockwise or anti-clockwise would give us this rotation. And it's at 4, between 2 and 3, 4, 2.5. So that's pretty straightforward, but most problems aren't as easy as that. So let's have a new problem where we draw an object, the object, or the image rather, over here somewhere. So let's see if we can draw it over here. Okay. And again, what we've got to do is find the centre of rotation. Well, this time it's not at all so clear where we're going to find it. We can guess, I suppose, that it's in this area here, and that it's going to be one of these corners maybe, but we just don't know which one. So we have to now, because we haven't got a centre at the origin, clearly it's not at the origin, then what we have to do is use a geometric method. So what I'm going to do is label up the vertices again, so A, B, C, and we know that this is A prime, B prime, and C prime. Let's just redo that, make it look more like a C. Okay. So, how do we find the centre of rotation? Well, let's keep that colour. If I draw a line from one of these vertices, so from A prime here, going in a horizontal direction, then because it's a 90 degree rotation, in fact let's make sure we've specified that, so everything we're doing now we'll have as a 90 degree fixed rotation, so that's going to be a 90 degree rotation anti-clockwise. Let's notate that AC, so an anti-clockwise 90 degrees rotation. If we draw now horizontally here, then from A I need to draw a line vertically, so let's draw a line down then from A, and that begins our attempt to find the centre of rotation. Right, now I need to think of these horizontal and vertical components in a rotation. I need to think of them as equal. In other words, the horizontal component and the vertical component of the image will be equal to the horizontal and vertical component of the object. So if, for example, I count, let's say count 8 along to here, okay, then that's the horizontal component. The vertical component from the object, that must be the same as well. So 5, 8 to here. Okay. Now, if I look at the horizontal and vertical components from here down to the center of rotation, I'm assuming that it's there. But if I draw these down, I think you can see very clearly, and this one across, okay, I think you can see very clearly that I don't have a center of rotation, because although these two lengths are the same, these two are very different. And they have to be the same as well. So this can't be the center of rotation, so let's have another go. So what I need to do now, let's just erase these. Oops. Okay. What I need to do now is find, so it's a bit of trial and error really, this process, is find another length that is going to give me an equal horizontal and vertical component down here. So if I've tried 8, it makes sense to try 7. Let's go one back, try a length of 7 here, and so it's going to be a length of 7 on this one as well. Let's just delete these other marks so I don't get confused. Okay, now I can see, in fact, already that if I join down from here, that will go down 3, and I go along from here 3, I now have the center of rotation. So I was quite lucky there. It just took 2 attempts and I got to the center of rotation. Now, what that means is that any point from the center of rotation will map on, for example, this will map onto this point here. So if I take a pair of compasses and put the point at the center of rotation, I can then draw my compass round 90 degrees in an anti-clockwise direction, and it should map onto this point here. Okay, and now you can see more clearly how these two horizontal and vertical components are the same, they're just rotated 90 degrees. Now as a check, well, let's just put the solution in first. So the solution is that the center must be at, where was it? Here. So it's 1 along, 2 down, so it's at 1 minus 2, negative 2. Okay, that's good, but let's do a check. So what I'm going to do now is use my compasses again, because as I say, any point now should map onto its image. So let's try A from the center of location, stretch my compasses and draw again round, and hopefully I will reach, I do, the A prime. So that's enough to be certain that this center must be correct. Now let's try a slightly different problem. What if I know my center of rotation? Let's just get rid of these. What if I know my center of rotation, but what I don't know is where it's going to, is where the image is going to be. So I'm going to go back to drawing again the image of my object, but this time the center of rotation is not going to be at the origin. So again, I have to use a geometric method. So we'll call this problem F. We'll set then the center at, let's say 1, 1. 1, 1, keep it nice and simple. So here. And I want to then again rotate by 90 degrees in an anti-clockwise direction. So if I'm not going to use the method that I used earlier, how am I going to do it geometrically? Okay, well actually it's fairly straightforward. If this is the center of rotation, I'm just going to make that a bit clearer, like that. If that's the center of rotation, then let's consider point A, okay, the vertex A. From the center of rotation, I have to go along 3 to get myself under A. So I could draw a line across there, but then when I rotate that line, I'm going to rotate it up here. So if I've gone along 3, the very simple thing to remember is I have to go up 3. So if I went along horizontally 3, then I have to go vertically 3. Okay, so now I can draw a line up in this direction. And in fact I can confirm that again using my compasses by just drawing around from this point here. Okay, so we can see that's a 90-degree rotation. Now from this point I simply have to draw along 1, 2, 3, 4. So again, if this is vertical, this is going to be horizontal. Okay, so now we've got A prime. Let's find the other 2 points. So let's go for B and find B prime. So again, from my center of rotation, let's change the color. I would have to go along 1, so let's now go up 1 to here and along 1. Now this time I don't go up to get to my vertex, I would have to go down 1. So in a similar way I need to go not along in the same direction I went before, but along, there we go, along this way to there. Okay, and finally, again let's just change the color so we can see it very clearly. To get to C prime, hang on, let's just mark B prime. So you need to be really careful here to get everything correctly labelled up, otherwise you're going to make a mistake. So to get to C prime, again, what would I have to do? I would have to go along, this time 1, 2, 3, 4, 5. So I'd have to go along 5. So I need to go up 5 to there. Okay, let's use my compasses again to see if this is a rotation from here. It's worth just checking. I think it makes it a bit clearer what this line is doing. And now, again, I simply go down from here 1. So not up, but down 1. So I need to draw the line across to here. Okay, so now let's label up that point as C prime and join all of these vertices, these 3 vertices together. Okay, and just fade those out. There we go. So fairly straightforward operation, and this is the sort of thing that you would get in a GCSE exam. So if you have a missing centre, then you have to use a kind of trial and error method to find the centre. Finding the centre is really important. Once you've found the centre, then it's a fairly straightforward operation. If you've got the centre, it's a fairly straightforward operation to give the coordinates of the point. So let's just finish by writing down those coordinates. So we've got A prime is -3, 4. B prime is 2, 2. And C prime is 2, 6. Okay. So let's go back finally to rotation about the origin, which is where we can get some really interesting mathematics and not just work geometrically, but work with the formula that we looked at. Now, it might have occurred to you that it's quite a hard thing to memorize. The 90-degree x and y components, what happens there, the 180 and the 270. There's three things to remember there, and it gets very confusing, very muddled. So, is there an easier way to remember all of that? In other words, wrap it all up in one straightforward formula? Well, the good news is there is. And so let's have a look at that formula straight away. What we're doing is we're looking, first of all, if you remember, we're trying to find the x component of the image. Now, the x component of the image is actually, with any rotation, whether it's 90, 180, 270, or any other angle, it's going to be some multiplier times the x component of the object plus some other multiplier times the y component of the object. And the same with the y component of the image. The y component of the image is some multiplier times the x component of the object plus some multiplier times the y component of the object. Now, don't worry if this sounds a bit confusing at the moment. You'll see what I mean in just a moment. But keep your eye on these gaps here, because these are the gaps that we're going to fill in. And once we've done that, we'll then have a way of memorizing this so we can use this formula much more efficiently, so we can get to the answer. Okay. So, what do we fill in here? Well, for the x component of the image, we fill in this, cos theta. So whatever the angle is of rotation, we're going to take the cosine of that angle. Okay? And we've got to add the negative sine of the angle times the y component. That's the first part of this general formula, so that we just have to remember one thing. So that's the first part, that's the x component, that's this one here. Now for the y component of the image, well, that looks rather similar, and that's why it's quite easy to memorize. So it looks like this. So this time the sine and the cosine are around the other way, and we don't have this negative. So there's only one negative in the whole formula, that's up here. We have to remember to make the sine of the x component of the image, we have to remember to make that negative. Other than that, it's just cosine, sine, sine, cosine for the y component. All right, now let's see this in practice. Let's see if we can get back to what we had before, just from this general formula. Okay, well, let's start with 90 degrees. Okay, the 90-degree rotation. So if we want to find the x component of the image, we need to find then the cosine of 90 degrees and multiply that. So what's the cosine of 90 degrees? Well, if you've got a calculator handy, that will tell you the cosine. But you probably know that the cosine of 90 degrees is just 0. Okay, so the first one here, what we can fill in here, is just 0. So in other words, there is, when you've got a 90-degree rotation, there is no x, or it's a 0 that we multiply by the x component of the object. So that will cancel that out, okay, and we can move on to the y. So we need to add what? Negative sine of 90. Sine of 90. So the sine of 90, again, you'll find it in your calculator, or you should, I guess, just know it. The sine of 90 is 1. So we're adding negative 1 times the y component of the object. Now we can simplify this nicely, because 0 times anything is 0, so we can just cancel that out. Okay, and minus 1 times the y component of the object is minus 1 times the y component is, in other words, negative, the negative of the y component. And that's exactly what we had before. So at 90 degrees, the x component of the image is the negative of the y component of the object. All right, so this formula works. It simplifies down to exactly what we had before. Let's see if we can do the same with 180 degrees. Okay, once again, we need to work out the x component of the image. What happens this time? Well, the cosine of 180 degrees is negative 1. So if we fill in negative 1 times the x component of the object, and we add, again, the negative component, negative sine of 180 degrees. And sine of 180 degrees is the same as sine of 0. In other words, it's 0. So sine of 180 degrees is 0. So minus 0, well, that's just 0. So we add 0 times the y component of the object. And again, this is going to just simplify it down nicely and give us exactly the shortcut that we had before. So this will cancel this time, and that gives us x component of the image is negative x component of the object for 180 degrees. So you just make it negative, in other words. Okay, now let's go back and do the y component of the image, and we'll finish then with 270. The y component of the image is sine of 90 degrees, or cosine of 90 degrees. Cosine of 90 degrees is 0. It is sine of 90 degrees. So sine of 90 degrees is 1. And we've got the x component of the image, so that's just x component of the image, of the object rather, plus positive cosine of 90 degrees. So positive cosine of 90 degrees, well, that's 0, so it's plus 0. So we've got y of the image equals x. So again, exactly what we had before, but we're taking it now just from this general formula. Let's do the 180. So the y component of the image again is the sine of 180. 180 is 0, so that's 0 times the x component, plus the cosine of 180. And the cosine of 180 is minus 1. So again, we've got minus the y component of the object. So does it work for 270 degrees? Let's try. So we've got 270 degrees, the x component of the image. Let's have a look. Well, the x component of the image, again, we go back to this, is the cosine of 270 degrees now. Cosine of 270 degrees is 0, so we don't need to worry about the x component of the object. Negative sine of 270 degrees. Sine of 270 degrees is minus 1. So we've got minus 1 times the y component. So that gives us x component of the image is minus times a minus. In other words, just the y component of the object, exactly what we found before. Finally, the y component of the image is the sine of 270 degrees, which is negative 1, times the x component of the object, plus the cosine of 270 degrees, which is 0. So we don't have to worry about the y component. So the y component of the image equals the negative x component of the object. So in fact, we've derived all three of these formula, if you like, for finding out the coordinates of the image for each of these rotations. You might want to go ahead and try something like 45 degrees. What would happen if you plugged in 45 degrees? Or if you wanted 15 degrees clockwise, then 360 minus 15, then you've got 345. Try that. So it's not essential, and certainly not something that we usually expect to use in GCSE examinations, but I think it's good to know that there is this general formula and you can use it to find the coordinates as long as we have the centre of rotation at the origin.